Alright, in this video we're going to see some examples of evaluating logarithms. So we did see some of those in an earlier video, and we're going to recap what we said there just because it is pretty important, and I think it's a very helpful way to think about logarithms, so I do want to emphasize that with its own separate video. So if we say something like the base b logarithm of the number a, okay, then what is that? How do we find that? Well, the way we can think about that is the base b logarithm, let's make that a little nicer, logarithm, a little better, of the number a is the number that b must be raised to in order to get a. Okay, so again, that might sound kind of weird or confusing, but once we see a few examples, it'll become pretty clear what's going on here. So if we say the base b log of a, find out what that value actually is, then what we ask ourselves is what's the number that b has to be raised to in order to get a? The base b logarithm of the number a is the number that b must be raised to in order to get a. So let's see some examples. So we'll just recap some of the examples we talked about before jumping into some other ones. So if we say the base 2 log of the number 8, what's that? Well, if we use this interpretation here, the base 2, okay, b is the base is 2, and a is 8. The base 2 logarithm of the number 8 is the number that 2 must be raised to in order to get 8. What does 2 have to be raised to in order to get 8? Well, if we take 2 and raise it to the third power, we get 8. So that's how we evaluate this logarithm here. And really, that's how we evaluate logarithms in general. Okay, so the base 2 log of the number 8 is 3, because if we take 2 and raise it to the third power, we get 8. Okay, now let's see another example. What if we, I'm trying to find a better color here, what if we have the base 7 logarithm of the number 1? What does that equal? Well, here, b, the base b is 7, the number a is 1, so the base 7 logarithm of the number 1 is the number that 7 must be raised to in order to get 1. So what does 7 have to be raised to in order to get us 1? Well, if we take 7 and raise it to the 0 power, that gives us 1, right? So remember that property of exponents. If you take a number that isn't 0 and raise it to 0, you just get 1. Okay, so 7 to the 0 power is 1. So we have that going on there. Okay, let's see one more simple example, then we'll jump into some more complicated examples. So let's say we have something like the base 5 logarithm of 125. What does that equal? Well, base b log of a, so b is 5, a is 125. The base 5 logarithm of the number 125 is the number that 5 must be raised to in order to get 125. So what does 5 have to be raised to give us 125? Well, what's 5? 5 to the first, let's come off to the side and see some values here. 5 to the first is 5, of course. 5 squared is 25. What's 5 to the third? 5 to the third is 5 times 5 times 5. Okay, 5 times 5 times 5, which if you toss that into a calculator or work it out by hand, you'll see that that's actually 125. So the answer is, again, just like it was over here, the answer is again 3. Okay, so the base 5 logarithm of 125 is 3, because 5 to the third power is 125. Okay, so the base 5 logarithm of the number 125 is the number that 5 must be raised to in order to get 125, and 5 has to be raised to 3 to get 125. Okay, so let's look at a couple examples that are a little more complicated than that. But no matter how complicated they are always going to follow that same pattern there, so we can always think of it in these terms that we've outlined here, with this interpretation here, I mean. Okay, so let's say we have this example. Whoops. What is the base 2 logarithm of 1/4? So that's a little trickier, right? because we have the 1/4 here. It's still possible. It still makes sense to talk about this. It's just a little trickier. So the base 2 logarithm of the number 1/4 is the number that 2 must be raised to in order to get 1/4. So in other words, 2 to what equals 1/4? Well, how are we going to find that out? Well, so this 4 kind of jumps out at us, right? 4 kind of jumps out as a clue. So what is 2 squared? We know 2 squared is 4, right? Well, how are we going to get from 4 to 1/4? Or is there even a way to do that? Can we somehow get a 1/4? Well, remember the rule that if you have something like a negative exponent, if you have something like this, then you can rewrite it like this. So negative exponents like that, you can push them into the denominator. If negative exponents are up here like this, you can push them into the denominator and then they become positive exponents. So 2 to the negative 2 is actually 1 over 2 to the positive 2. So remember that rule of exponents. And then 1 over 2 to the positive 2 is actually 1 over 4. So that's how we can do that. Okay, if we take 2 and raise it to the negative 2, that gives us 1/4. So that means that this logarithm is actually negative 2. Okay, because again, the base 2 logarithm of the number 1/4 is the number that 2 must be raised to in order to get 1/4. And we just found out that 2 has to be raised to negative 2 to get 1/4. Therefore, the answer is negative 2. Okay? Because remember, the logarithm is just the number that the base has to be raised to in order to get this number here. And if we take the base 2, raise it to negative 2, then we get 1/4. So let's see one more example like that, and that'll be it for this video. So let's clear some space over here. Now let's say we have, let's use this color here. Oops, got to stop doing that. Let's say we have the base, let's see, 3 logarithm of 1 over 27. What's that equal? Well, base b is 3, and then our number a is 1/27. So the base 3 logarithm of the number 1 over 27 is the number that 3 must be raised to in order to get 1 over 27. So in other words, 3 to what number gives us 1 over 27? Well, if we're good enough, or if we're familiar enough with exponents, then we know that 3 to the 3rd power equals 27. Okay, and if you're not sure about that, you could just multiply 3 by itself 3 times. 3 times 3 is 9, times 3 again is 27. So just like before, a negative exponent is going to help us get that fraction here that we want. So 3 to the negative 3 is 1 over 3 to the positive 3, which we know, 3 to the positive 3 we know is 27. So this is 1 over 27, which is what we're looking for. Okay, so then we just found out that negative 3 is what we have to raise 3 to in order to get 1/27. So one last time, the base b logarithm, or sorry, the base 3 logarithm of the number 1 over 27 is the number that 3 must be raised to in order to get 1 over 27. And we just saw that if we take 3 and raise it to negative 3, then we get 1 over 27. So the answer here is negative 3. Okay, so that's just a few simple examples of how to evaluate logarithms. And I really do believe that if you think of it in these terms here with this little sentence here, then that will really help you get comfortable with it and familiar with evaluating logarithms, which is definitely a good skill to have as you move forward in your math course.